Okay, so example number 5, oops, excuse me, we're in chapter 8, section 2, factoring by the greatest common factor. Should have started that way. In example number 5, we're going to be doing the most difficult factoring in this section. So I'm going to show you what we need to do. Okay, so just watch and, as always, pause it or rewind it if you need to. So let's start off by using my box again. And again, this will work if I do what we call the distribution method. Now, I already messed up. Sorry. I told you in the previous video to always put these in standard form, and I forgot. I just started writing it down without even looking. So I'm going to put the 10 over here and the negative 2x right here. All right, now, one thing to notice about this is called factoring with opposites, and we have a problem. Notice how I've got a negative here and a negative here, but I've got a positive here. Remember when we were multiplying, and remember when we were multiplying using the box method and everything, what we're going to have is this is going to be negative, and this up here is going to be negative. I don't know what they are yet. I'm going to figure it out. So I'm going to have positive, negative, positive, negative. That positive times positive is good. That positive times negative is negative. That negative times positive is a negative. And the negative times negative is going to be a positive. So I got to keep that in mind, right? So what do these two have in common? They both have a 3, and they both have x to the second power. What got left behind? The other x, 3x to the second power times another x is 3x to the third power. Over here, what got left behind? Negative 5. Okay, cool. What do these two have in common? This is negative 2 times x, and this is 2 times 5. So I have a 2 here. But look what happened. 2 times x is positive 2x. 2 times negative 5 is negative 10. I need to also factor out a negative. Now everything matches up. Negative 2 times x is negative 2x, and negative 2 times negative 5 equals positive 10. So this is 3x to the second power subtract 2, and this is x subtract 5. So again, one more time, what I'm going to notice is that if the last part is positive, but these two middle parts are negative, that means I'm going to have subtraction in both my terms, or both my binomials. All right, let's do a couple more examples. And this time I'm going to remember to put it in correct order, which actually is going to be confusing with that one. We're going to see how that works. All right, I got x to the second power, x to the third power. So let's turn these around. I'm going to put that there, and I'm going to put that there. Negative 10x to the third plus 15x squared plus 8x subtract 12. Negative 10x to the third power, positive 15x squared, positive 8x, negative 12. Now that's okay, but it also, I'm gonna show you something else, okay? Usually we don't want that first term to be negative, and there's a reason for that, okay? So a reason for advanced math. We usually don't want it to be negative. Okay, I'm going to go ahead and do it this way, but then I'm going to show you a different way of doing it, and both ways are okay. What do these two have in common? Well, they both have 5. Here's 2 times 5, and here's 3 times 5, so I'm going to put a 5 here. This is x to the third, this is x to the second, so I have x to the second power. All right, now hold on. I'm going to mess with the signs in just a moment, the plus and minus signs. This left 2x, and this left 3. But remember, a positive times a negative equals a negative. Positive times positive equals positive. So I'm thinking I'm going to put a negative in front of that 2x. So hold on to that thought for just a moment. What do these two have in common? Well, this is 2 times 4, and this is 3 times 4. So they have a common factor of 4. All right? But 4 times 2 is 8x, and 4 times 3 is not negative 12. I need to put a negative in there somehow. Okay, so where do I put my negatives? I can put a negative here. Then now 5 times negative 2 is negative 10. But 4 times negative 2 is not positive 8. But since I need to get a negative here, what if I put a negative in front of the 4? Now does it match up? 5x squared times negative 2x is negative 10x cubed. That's good. 5x squared times 3 is positive 15x squared. That's good. Negative 4 times negative 2, and negative times negative is a positive, positive 8x. And negative 4 times positive 3 is negative 12. Awesome. So I'm going to get 5x squared subtract 4 times negative 2x plus 3. However, here's a backup way of doing it. That's okay. Here's a backup way of doing it though. If you see the first term, the leading coefficient is negative, then factor out a negative 1. So I'm going to have negative 1 times positive 10x cubed, negative 15x squared, negative 8x, and positive 12. I just changed the sign of each of these. And that negative 1 is going to be there. And then, of course, I'll do this quickly. 10x cubed, negative 15x squared, negative 8x, and 12. This would be 5x squared and 2x, negative 3. And this would be negative 4. So here's my 5x squared minus 4, which is still there. But instead of negative 2x plus 3, I got positive 2x minus 3. So I get negative 1 times 5x squared plus 4 times 2x minus 3. So in other words, I factor out a negative 1 from here, changing that to positive and changing that to negative. And this is actually a better way of doing it, because like I said, we usually want our first term to be positive. So remember that. Let's do the last one for this video. Now I got x's and y's. I don't have standard form. Hopefully I can put it together somehow that it's going to make sense. What I'm going to do is I'm going to follow the pattern that we've been doing so far, where I've got positive, negative, negative, positive. Hopefully this will work. So again, I got positive 8y, negative 8, negative x, and positive xy. I just filled them in the way they were. And that follows the pattern of what we've been doing in this section: positive, negative, negative, positive. What do these two have in common? They have 8. Well, I got left behind here y, and over here negative 1. What do these two have in common? They have x. But wait, that didn't work. You know what? If I look at it, doesn't x times y equal xy? And doesn't x times negative 1 equal negative x? Oh, okay. I filled it in the way that it was, thinking this would work, but turns out it didn't. That's okay. 8y, negative 8. I'm going to switch these two. X times y, negative x. So it actually made more sense to line up the y's and line up the negatives. This is y subtract 1. This is 8. This is x. So I get 8 plus x times y subtract 1. And you probably won't see anything that difficult on the test, but make sure you know how to do it for the homework. See you in the next video.